All right, so in this video, we're going to talk about extreme values on closed intervals. And the title being on closed intervals is actually going to be very important down the stretch. So to start though, we're just going to talk about and define what we mean by extreme values. In general, we're going to distinguish between absolute value, extreme values, and relative extreme values. What I have up on the screen are definitions for an absolute maximum and an absolute minimum. The definitions are pretty basic, and I believe you can follow them pretty easily. And you'll see here in just a second, I can expand upon it a little further. Now, for an absolute max at x equals c, this is going to occur when f of x is less than or equal f of c for all x in D. Now, let's think about what that says. It says that we have an absolute max at x equals c where all values of y are less than this less than or equal to this one particular y value right here. So when all other y values are less than or equal to one particular y value at x equals c, we have an absolute max. This is true for all x in the domain of f. Okay? Similar on the absolute minimum at x equals c. All other y values are bigger or equal this one particular y value for all x in the domain of f. Okay, so when we talk about absolute max and absolute min, we're talking about the absolute highest point and the absolute lowest point on the graph of f on its entire domain. Okay, so that's the absolute max and the absolute min. Now, relative max and min really doesn't change a whole lot. We're going to keep these same definitions, but we're going to add in an open interval I containing C. Same thing down here. In an open interval I containing C. What this does now is not only does it use the word open, which is interesting considering I just mentioned how important close was. We'll get back to that. But what it does is it now says we don't care about the entirety of the domain. We want our interval to be within the domain, of course, but it's just going to be in the nearby vicinity of C. It doesn't have to be the overall highest point or lowest point. It just has to be the highest or the lowest relative to its surroundings or nearby. So when I add this blue line down here, now we're talking about a relative max and a relative min. Okay, so the difference between a relative max and an absolute max aren't that different. The difference between a relative min and an absolute min aren't that different. An absolute just means it's the absolute highest or the absolute lowest on the entire domain. Relative means it's the highest or lowest relative to its surrounding area. And so there's going to be a figure in your book that you're going to want to take a few minutes. Figure 4.5 on page 186. This is a really important figure that I think it would be a good idea if you paused the video, found this picture, and studied it for a few minutes to really understand what's going on. These concepts shouldn't be too overwhelming. They're very intuitive, but that figure is going to be quite helpful. Now, the last thing I want to say before moving on to a similar but yet different topic is the words absolute and relative. Depending on the textbook, another word for absolute can be global max or min, and another word for relative can be local max or min. Generally speaking, I use absolute and relative, but it completely depends on the textbook. These two words can be used interchangeably, as can these two words. Okay, so again, go to page 186, study that figure 4.5. When you feel good about what each of those things are, rejoin the video and we'll be ready to move on. Okay, so moving on then to the extreme value theorem. The theorem reads, if f is continuous on the closed interval AB, then there exists both an absolute max and an absolute min on that closed interval. That's where we're very, very clear in specifying we're on a closed interval. If f is continuous on a closed interval, we're guaranteed both at least one absolute max and at least one absolute min on that closed interval. Okay, so the question now is going to turn into, well, where might these exist? And there's always going to be two places you'll need to check. The first place is usually the easiest, the endpoints. Remember, we're on a closed interval, so those endpoints are on your graph. The second point would be at all of your critical values. Now, critical values are the C values in which you plug them into your first derivative, they give you 0. All right, now this is important to understand. Why? Hopefully by now you've started to piece a few things together. Okay, one of them is when we take our derivative, f prime of x, and we set it equal to 0, that's us saying our slope is going to be equal to 0. Well, the slope of our tangent line being 0 implies we have a horizontal tangent line. So when we take this and we solve it for x and we get c, we're saying that at x equals c, we have a horizontal tangent line. Okay, so for example, maybe I'll draw a picture like this, and right here might be our c value, and notice there's our horizontal tangent line. But what else do you notice happening right there? Well, that's going to be a maximum value. Okay, similarly, if I did something like this, maybe right there, this is where I'm going to have that horizontal tangent line, in which case you again now have a minimum. So those horizontal tangent lines, that's where we're going to be searching for possible maxes and mins. And again, hopefully you've picked up on a little of that so far. I don't know that it's been formally thrown at you like it has been now. But remember, these critical values, these are going to be really important moving forward. To find them, we take our first derivative, we set it equal to 0, and we solve it for x. Now, I've pointed out that we're going to be searching for these absolute extreme values at the endpoints and critical values. I'll close out this screen by once again mentioning to you figure 4.3 on page 185. That's a different figure than the last one. This is another picture, a couple pictures that I think will help you see why we search where we do, hopefully better than my green drawings on the corner of the screen. So take a few minutes, study figure 4.3 on page 185, and then we'll jump back in with some examples.